Hey guys, welcome back to Jyoti classes. And in the yesterday's class, we did about we started with the complex analysis. So we learned about what is the complex function and can be represented as its conjugate, and what are the identities, basic expressions to find whether it is analytic or not, and few of the remaining things like isolated and non-isolated. And but in continuation part, today we will be going to see about the order 1 pole and order n pole. See, order 1 pole is a simple pole. Okay, in this simple pole, where I can get the value of z just equating with it 0. If I just equate the denominator or any given z value, if it is in this form, if I equate it to 0, I can get the value as a. Okay, this I am getting the value. This is the pole of the given function. So this is a simple pole. So if we represent, that is limit of z tends to a, that the pole which we found, and the z minus a into f of z. If f of z is phi of z by xi of z, then xi of a is equal to 0 and phi of a is not equal to 0. To find its residue, phi of z divided by xi dash of the differentiation of xi dash of x, where z is equal to a. Okay, you will better understand when you solve this problems. Okay, let's learn the next one. Next, for the order info, just remember the formula and the way you have to solve this. Okay, next, for the order n pole, 1 by 1 by n minus 1 factorial into d to the power of n minus 1, z to the power of n minus 1, the whole bracket, z minus a to the power n f of z, where z is equal to a. If anything other than simple pole or of order 1 pole, you have to use this formula to find that. Okay, if you apply this formula here, basically you will be getting the question something like this. You will be having some function like f of z is equal to 3z divided by z minus 4. This is the sort of questions you will be getting. If, see, this is of order 1, is it? If it is order 1 pole, then the value of z minus 4 is equal to 0, that is z is equal to 4. It is a simple 4 at z is equal to 4. After getting that, when you apply in the limit, that is limit has z tends to 4, this is also z minus 4. What did I have the equation? That is 2z minus 4, cancel. So we have to, like in limit of z minus 4 is equal to 2z, just put the limit value and get the answer. In this way we will solve the simple pole. Okay, but for the order n pole, we will be having the function f of z is equal to I can say that it is 3z upon z minus 4 to the power of 3. See, the order is 3. The value of n is 3. Just substitute in this form, that is 1 by n minus 1 differentiation 3 minus 1 by dz by 3 minus 1. You will get an value here. After finding this value, find the residue. Okay, this is what important to solve for order 1 pole, order n pole. Okay. Next, so there are few of the tricks that you should be aware of. That is, for order n pole, you are solving and you will get some values. Like if it is something like sine z by z. Okay, this sine z is a removable function, is it? Then when you put the value of sine z, expansion value of the sine z, you will get somewhere in the form of 1 by z is remaining. Just take that value and that will be your residue. Okay, this is one of the trick you should remember. Just take the coefficient of 1 by z or 1 by t I have written here, and that will be the residue for yours. Okay, now coming back to the poles. If the poles are in the within the closed contour, Within the closed contour means if it is the contour given and it is ranging from 3 to 5 and your pole is lying at 2, you have a pole value that is lying at 2, then it is in the, sorry, for example take 4, then your residue will be in the form of I. It is lying in the closed contour, then I is equal to 2 pi I summation of r. Okay, the residue will be this one, and here it is anti-clockwise. For if it is clockwise, then it is minus of 2 pi r summation of r. Okay, so these are the way that you will get the final solution. In complex analysis, if any complex questions are there given, first thing what you have to do is, first thing you need to find the pole. After finding the pole, second thing what you have to do is you should find the residue. After finding the residue, for the final equation you have to put in I form, okay, which is the closed integration form, which is the value according to that you have to put. These are the three main steps to form any closed integration or any complex analysis given function. Okay, so next, here few of the values, that e to the power of I into odd of pi. Odd of pi here I mean e to the power of I 3 pi. Then the value will be minus 1. You will get some these sort of values when you solve the questions. Okay. Next, e to the power of I theta is cos theta plus I sin theta. And these are the direct formulas which I have written here, so that it will help you out whenever you see the question without taking much time solving by the procedure. Just see and apply in the formula. That is, if the given formula is something like 0 to infinity dz by 1 plus z to the power of n. 1 plus z to the power of n, I mean if it is something like 0 to infinity, integration 0 to infinity, just see the integral sign also, dz by 1 plus z to the power of 2. If I say here 2, that is your n value, just simply put pi by 2 cosec of pi by 2. What is the value of cosec pi by 2? You will directly get the value. In that way you can solve the question without going its regular step. This is done. And for if the integration is from 0 to 2 pi, and that is d theta by a plus b cos theta. Here the equation will be something like 0 to 2 pi d theta by a, I can say 3 plus 2 cos theta. If you have some equations like this, for cos theta also, for sin theta also, you have the value of 2 pi root of a square minus b square. Just directly take this 2 pi root of any value of root. Here I taken 3 and 2, that is 9 square minus 4. You will get something like 2 pi by root 5. This will be your answer. Okay. Next, for the given question, integration lying from 0 to pi, that is d theta by a plus b cos theta, that is equal to pi divided by root of a square minus b square directly. If it is 0 to 2 pi, 2 pi by root of a square minus b square. If it is 0 to pi, then pi by root of a square minus b square. As simple as it is. Okay. So these are the formulas you should be aware of, so that you can directly solve the questions without wasting much time in this. Next, and related to that only few more formulas for contour integration. That is, as I said before, 0 to 2 pi. You can here in place of pi I have written x. Okay. For 2 pi, if it is sin theta or cos theta, same thing, and this is also the same thing. For 0 to pi, pi by root of a square plus sin square theta, it is root pi by root of 1 plus a square. Just take the value of a square and differentiate, you will get this answer. Next, if it is 0 to 2 pi sin square theta by a plus b cos theta d theta, that is equal to 2x by b square, that is a minus root of a square minus b square, and the condition a greater than b greater than 0. Okay, these are the few more formulas of contour integration that you should be aware of. Okay, so just make a note of all these, and we will be solving these questions. While solving the questions, I hope you should be clear with all the basics things to know contour integration questions. Okay, so this much for today's class. Thank you guys.